because I always forget to do that. From an update standpoint, the only thing I want to mention, there wasn't a lot to provide updates on this session, is KubeCon North America, obviously be virtual. That is November 17th to the 20th. I believe it's only like $75 for access to all the sessions. They also host, one of the nice things you should look at is also they have what are called co-located events. So they have a lot of different ones on Cloud Native Data Management, Open Operators Day, Service Mesh Day. So definitely check those out. But that's really all the updates I had for today. So I will hand it over to Steve.
All right, cool. Thanks, everybody. Great. So yeah, today we're going to talk about Kubernetes networking, specifically in Azure. So I'm going to run through a good bit. I want to keep it pretty casual. We're going to dig into primarily, let me share my screen really quick, primarily the network plugin side of things. Let me actually switch this over. As I'm talking, like I said, I want to keep it casual. So if there's questions, drop them into the chat. I may not see them, so maybe Kendall and Dave and others can chime in. We're going to cover a good bit, but again, primarily the focus is going to be on the network plugin side of things. So KubeNet versus Azure Cni. If you're interested in some of the more securing of clusters, outbound type, right? So how do you handle egress traffic from your cluster and sending that the way you want? That was covered by Ray Cal about a month and a half ago, I guess. So the link is provided in this GitHub repo. I'll share the repo at the end so everyone has access to it. But you can jump out there and take a look at that talk from Ray. And again, everything that I'm covering today is in this Git repo and these docs. I'll share them at the end. We're going to probably go a little bit deeper than some people may be comfortable with, maybe not as deep as other people. But don't worry, you can catch the recording if you want to kind of recap anything, and you can always go through and run every command that I ran within here. Okay.
Can you share this link, please?
Yeah, I'll share it at the end. I don't know, just so people aren't kind of jumping too far ahead. But yeah, absolutely, I'll share that. Cool. All right, so let's talk a little bit about what these network plugins are, right? So when you're creating a AKS cluster, there's a couple key decisions you make around networking, right? So the outbound type is one, the load balancer type is another, right? So how's traffic coming in and out of the cluster via load balancer is going to be basic or standard. Network policy is another one that I'll touch on a little bit later, but probably the most fundamental one that you'll deal with is the plugin itself, right? And there's two options that you get when you're deploying an AKS cluster. The first is KubeNet, and the second is Azure Cni. And by the way, KubeNet is default, right? So it's the default implementation. So what is KubeNet? What does this actually look like? Okay, so if you're looking at a KubeNet cluster, it comes down to a few fundamental things. Hopefully you can see my drawing board here. So in a KubeNet cluster, you're going to have your AKS instance sitting in some virtual network within some subnet that you've defined in Azure space for, right? So in this case, we're 10./16 for the VNet, and then we've created a subnet called 10./24, right? And within there, we have our AKS cluster. So what KubeNet does is when it creates the AKS cluster, it creates what's known as an overlay network, right? So an overlay network is a network that kind of sits on top of your actual network, right? So if this was our Azure subnet, it's 10./24, we're going to have an entirely different network within there, right? So you're actually going to define when you're creating your cluster what's known as a pod cider, right? So what address space, what cider should your pods be sitting on? Okay, so that overlay network gets laid into the cluster, and all of the pods that are created within your cluster are going to get addresses from that address space. Okay, so what ends up happening is, that's great, right? Because it's good for a couple of reasons. First of all, if you're restricted on the amount of address space that you have, then no issue, right? Because you can have a massive address space within the cluster that's invisible effectively from the outside, right? So that's good. So if you're very tight on address space, KubeNet does some nice things for you. Out of it, if we take a look at this path, right? So if I'm a viewer, say I'm like a Microsoft InfoSec person, you can't see my shirt there, right? And I'm watching traffic kind of coming in and out of here. What I actually end up seeing, and we're going to dig into this a good bit deeper, what I actually end up seeing is not the pod IP. So if I'm seeing traffic coming to me or coming to a database or coming somewhere else, I'm not actually getting the pod IP address. That pod IP address is in this imaginary, effectively overlay network. So it ends up getting source natted to whatever the node IP address is, right? So we'll show that flow and what ends up happening there, right? So, pros and cons, right? The pros, you get the additional, flexibility around address spaces. Cons, you don't have as much, control. If you wanted to say implement on this side, like an NSG, right, to apply some control there, or maybe you have a route table that you want to apply, right, on your Azure network. You don't have that flexibility anymore with Kubernetes. There's really not much you can do there, at least as far as the pods are concerned. You can obviously apply things to the nodes themselves, but you're not going to get pod level control. Okay, so checking the alternate option. So kind of moving this over here, Azure Cni. So what is the difference with Azure Cni? So Azure Cni takes a slightly different approach. And again, we'll dig into this a little bit more, but I wanted to give kind of the foundation of this first, right? So what Cni says is instead, rather than using Kubernetes, which is the default network plugin, we're going to plug in our own. So there's a Kubernetes container network interface specification that anyone can go out. It's actually not Kubernetes, so I should say it's not Kubernetes. It's container network interface is a specification that can be used by anyone to build a network plugin, right? So it's used by Mesos, it's used by Kubernetes, Docker, all these different organizations use the Cni specification. So what you end up doing is when kubelet starts on each of these nodes, right? So the agent that's effectively responsible for managing that node, when it starts, it references Azure Cni as a network plugin. So there's a instance of the executable, the agent for Azure Cni on every one of these nodes. So what it does is, as you're adding pods to the node, rather than giving your pods this overlay network, it actually gives the pods IP addresses directly from whatever subnet they reside within. Okay, and again, we'll dig deeper, but effectively how this works is every node is pre-allocated a certain number of IP addresses, right? So if you were to go in to the Azure portal and take a look at an individual node, you would see by default, I think it's 30 IPs per pod, right, for pods. So 30 pod IPs, I should say, right? And one node IP, right? So what happens is as this machine starts, Azure goes in and says, okay, well, the default number of pods is 30, which you can configure as you're creating node pools, right? The default number of pods is 30. So we're going to give this node 30 IPs plus one for the node itself. So we have, effectively 31 IP addresses here, and those can be consumed from within this node. So as pods are coming along, something, which we'll get into in a second, is basically giving those IP addresses to those individual pods, okay? Now, as traffic is leaving those pods, traffic is coming and going, again, if I'm the InfoSec person here, what I actually see is not the node IP like we saw on the Kubernetes side. I'm actually seeing the pod IP, so 10./24, 10.21, right? So I'm actually getting that IP address there. And that would be the same across all these different nodes, right? So on the pro side, you have fine-grained control over network traffic, right? So again, getting into, my pen just broke, getting into things like NSGs that I might apply here, right? Route tables, right? All those different things you might apply here, you have much finer grained control over those. Visibility from external viewers. There's a bit of a caveat to that I'll get into in a little bit, but much more control. There's also argument to be made that this actually, from a performance perspective, ends up being better. It does technically, if you get down into the weeds, which we will, reduce hops. That's probably really only impactful for like huge latency intensive workloads that you might have, but it'd be interesting to keep an eye on. I mean, if you are noticing network performance issues on a cluster, and you haven't tried Cni, it wouldn't be a bad shot to check it out and see if you see any performance differences there. But ultimately, I think it should be fairly negligible on that side. Okay. At the high level, any questions on that before I start to dig in? We're going to go a good bit deeper into each of these implementations and how they actually work. I'll give it a second. All right, cool.
Steve,
All
I
right,
think
so
there's one question.
Sure.
Does
There it is.
pod and node use same Cider?
So in Azure Cni, yes, they are the same Cider, right? So the pod Cider, in fact, you'll see when we go to create a cluster, you don't even provide a pod Cider for Cni. It just assumes it's the subnet Cider. Actually, I was just on a call with someone yesterday who was asking if it's possible to create separate pod ciders. To my knowledge, and it's certainly not supported in AKS today, but this individual was saying, look, in AWS, we currently have multiple address spaces that we add, and then to a given VPC, and then we have multiple pod ciders within the cluster. That's not something that's supported today, but something that maybe something we can explore in the future. See another one here. Is it viable to create NSGs related to pod IPs? Won't those relationships always be changing? Yes, it's a good point there. So if you create an NSG associated with a pod IP, that could change. You could also make it static if it's so in rare occurrences, but also you could do address ranges, right? So you can have you could leverage address ranges for that as well. But yeah, creating NSG specific to pods isn't necessarily the best idea. But if you do need to do that, you have the option better with CNI than you would with Kubernetes. I mean, ultimately, if you're doing that level of network control, you should really be looking at a network policy option like Azure Network Policy, or preferably Calico will give you a lot more control. All right. Okay. Can we increase the 30 pods per node limit? Yes. So that is a flag when you're creating a cluster, and I believe you can also set it at the node pool level. How many pods you can have per node. I'll come back to more questions in a second, but let's start to dig in a bit here. So again, if you look through this doc, everything that I'm going to run through, you have access to. You can run through these things yourself, and I'll share this link. Let me zoom in a little bit here. But in order to kind of, the way that I like to get familiar with these things, and I imagine most of you are the same way, is really to kind of dig into the guts of how this is working. So in order to do that, I created a couple clusters here. So this set of commands will basically go and create I'm not going to make you watch me create clusters, but effectively what I'm doing is I'm creating a resource group. I'm creating a virtual network with 2 subnets. So I have a subnet for my my Kubernetes cluster, and I have a separate subnet for my Azure Cni cluster. Okay, so that's all that's doing. And then we're going to jump into actually creating a cluster. Now I do make a note here. So if you look at this, and actually Ray brought this up to me, and I just kind of been blindly typing out this command, and Ray made a good point. Basically, if you're going to create a cluster and you want to have control over these address spaces, first of all, in this case, the few things to note here is that I'm creating a cluster, calling it Kubernetes, but the important thing is here I'm setting the network plugin flag to Kubernetes, which again is default. So if you don't set it, this is what you're going to get. I am, in my case, giving it a subnet ID that it's going to deploy to, because we just created a couple subnets. But then I am setting pod cider, service cider, DNS. These are all optional. You'll see what the defaults are. I can't remember what they all are off the top of my head. But if you don't set them, there are default pod service and DNS service IPs that get applied for you. But effectively what this does is this drives what IP space is used for the pods. Like, what is that overlay network? So the pod cider here, you'll see I'm giving a 10.100/16, fairly sizable address space for my pods. The service one is the one that Ray made a point about is, /16 is fairly large for services. I mean, that's an awful lot of IP addresses for services. So I made the point, I didn't change it in here just because I was too lazy to change my screenshots. Maybe I'll change it later. But I did make a point above to make sure you're aware as you're setting the service cider, generally the service cider doesn't have to be big. It certainly doesn't need to be as big as your pod cider, because in Kubernetes, if you're deploying a bunch of applications, maybe you're going to have 1,000 pods fronted by maybe 20 services, right? I mean, depending on the size of your deployment. So you're pretty much always going to have fewer services than pods. But along those lines, a thing to keep in mind is this service cider is not part of addresses. Even in Azure Cni, this service cider is always effectively an overlay network. It gets implemented really via IP tables, which there's a doc kind of towards the end. If we have time, I'll dive into how that all works. But the service cider is really just translating to a bunch of IP tables rules, which effectively makes it look like an overlay network within the cluster. So it never associates directly to your subnet. The only way you get a service exposed from your subnet address space is by creating a service subtype load balancer, right? Which you'll see if you look at this Nginx deployment that we're doing here. I think I may have said it's load balancer. If not, I'll show you where that setting is, right? So that will drive the creation of a internal or external load balancer, depending on how you create that service definition, okay? Only other thing here, I enabled managed identity. That's just kind of, I think, good practice overall, but really doesn't relate anything to the networking side of things. Okay, so then you go and create the cluster, get the credentials, And in this case, I created a Nginx deployment here. All right. So let me jump over and let's actually take a look at this. And I'm going to keep another screen on this side because there's a bunch of commands that we're going to jump into here that I wanted to share. Okay. So first things first, let's go and make sure that I'm on the right cluster. So, okay. Oops. All right, cool. So I'm on the right cluster. Get my nodes, not Nin does. All right, I'm going to grab one of these. Now I've gone and set this cluster up with SSH jump. I've kind of configured it for SSH. I have the commands in there to do that, or you can reference the Azure doc for that. Let's also take a look at our deployment. Let's get pods, or let's do services and pods. So in the doc, I do have an Nginx deployment. It's just basically a, oh, I scaled this down. Let me scale it back up. Scale that back up. Okay. So let's do that again. All right. So I have 3 pods. The way that I've set this deployment up, if you actually look at the spec for it, the manifest for it, what I've actually done is I've used effectively a topology distribution. So it's going to make sure that there's a copy of this pod across each node. It just makes it more interesting from a network perspective. All right. So let me zoom back in here. Okay. So as you'll see here, if I do switch this to an out wide, you should see that there's a copy of this Nginx pod running across each of my 3 nodes. And then I have this SSH jump because I'm using that to SSH into our nodes here. That's just basically a jump server pod. Let's get the nodes again. This is a really cool utility if you're trying to SSH into nodes. So you see it's going to take me right through that jump server directly into my node here. So, what I thought would be interesting is to, let's start from the container level and walk our way back, right? We got about, I'll give myself like 20 minutes to run through all this. So, if we want to look at the containers, the first thing we can do on there is actually look at what's going on out here. Let's see what containers are running. So I can see if I look here, if I do just a Docker PS on the node, I can see a Nginx image running here. You can see I also have this pause container running. So if I actually do Docker PS grep Nginx, one thing to be aware of, let me actually clear this and run it again so you can see a little bit better. If I grep Nginx, there's actually 2 pods here. This is part of the magic of Kubernetes and the fact that you have pods, right? There's a container for Nginx, but that container is within a pod, right? So that's why we have 2 here. That pod is essentially bootstrapped by this pause container, sometimes referred to as the almighty pause container, right? So this is the container that kind of kicks things off, that kicks off the network namespace creation and all those different fun details that make pods. And then you have a that you want to run in here. So ultimately, a container is just a process. So let's get the process ID for that. I'm going to do let's do inspect, Docker inspect. Again, all of these commands are within the doc, so you can grab these yourself. I'm basically going to inspect the Docker instance, the container, and grab the process ID from it. Cool. So the next thing I'm going to do here is what I really want to see is I want to execute a command within there to see what the network information is on this container. So I could just do Docker exec, but you can also run nsenter to essentially enter the namespace of that process, right? So I'm going to go into the namespace and execute a command within there, right? So if I nsenter and then I have it run IP address, you can see within that within that container, this is my network interface information, right? So I have loopback, okay, that looks familiar. And then I have this eth0 set up here, okay? So this looks pretty straightforward. But what is that? I mean, eth0 at IF13, like what the heck does that mean? That doesn't look fairly normal if you're used to Linux networking. So it turns out that at is an indication of a link, right? So it's linking something to something else. So if I look at my local host network, you can see that I actually have a 13, right? So this 13 is a link. So this interface on my host is linked to that IF3, right? So this is creating essentially a virtual Ethernet link between a kind of external interface and this kind of container internal interface, okay? Another interesting thing about this is you can see that it's on this CBR0. So if you go and look at the KubeNet documentation, you'll see that CBR0 is actually the bridge network that all pods get joined to in KubeNet. So if I take a look at that, I went and installed bridge utils. So if I do bridge CTL show, it'll show me all of my VF interfaces that are on that bridge. So we're starting to see now how this actually works, right? So if we were to kind of switch over here for a second and start to kind of walk this back, okay, from this side, look, we have a couple containers. Say I had 2 containers in a pod, Nginx and BusyBox. You can see that they have this interface number 3. It's indexed number 3, and it says at IF24. If I kind of walk this back to the pod level view, you see the pod has this virtual Ethernet interface, and it's at IF3. So both of these are number 3. That's where the linkage is. So these are all linked together. They have the same IP address. Again, this is KubeNet. So 10.100.117, 10.100.117, same IP address, all within that, that virtual Ethernet link. And then that, as we just saw, is actually connected to this bridge, right? This CBR0 bridge. And if I take a look back here, again, if I go to do IP address show here, and I take a look at that bridge, you can say, boom, there's my iNet, right? So this is my pod cider. So now we've kind of walked the whole way through. I said, okay, well, from a container, it gets connected, linked to an Ethernet bridge at the pod level, or sorry, to an Ethernet virtual Ethernet interface, which is connected to this bridge that then has its address space. So all of the networking that's happening there is basically these pods are getting their address space from this bridge. And this whole structure that you're seeing here on this page is basically constructed by KubeNet. So KubeNet builds all this out for you. That's kind of the magic of KubeNet. It just does the raw Linux execution to create this entire structure, okay? And then that bridge is effectively connected to this Ethernet, right? And that's where traffic flows in and out, okay? So one thing I wanted to show is, okay, so we have this bridge. Like, how does the traffic actually route? So if I take a look at the routes on the host as well, let me zoom this in a little bit. Let's clear it and run it again. Okay, so a couple things to be aware of, right? So if we take a look specifically at our bridge network, what it's saying is, hey, look, any traffic destined for 10.100, and this is /24 basically, send it to the bridge network, okay? Any other traffic should really go to ETH0. So then what's happening is, this is a /24. Well, if we look across our nodes, what ends up happening is each node actually has its own /24. So let's jump out to, once the traffic leaves the node, how does it know where to go? So think of this situation where I'm, again, if we switch back over to this view really quick, if I'm on node 2, I'm pod on node 2, and I'm trying to call pod on node 1 or node 3, okay, I know how to get my traffic to the Ethernet, right? I saw the bridge, I saw the IP addresses, I saw all that stuff. How does that traffic actually flow? That's where the kind of Azure part of KubeNet comes into play. So if we actually go and take a look at one of our resource groups, our managed cluster resource groups. So this is the resource group that was created when I created my KubeNet cluster. One of the things you'll see in there is this route table. You'll always see this with KubeNet clusters. You'll see this route table created, okay? So this route table, what it has is, you'll notice there's a /100, 024, 102.24, 101.24, and we happen to be looking on this side at 0.24, right? So what this route table says is, hey, look, if traffic leaves a node and it's looking for anything in the address space of 2.0.24, this is the next hop. Well, that next hop happens to be the node IP, right? So that's really what's handling this transition of traffic. It jumps out, it hits a route table that AKS creates and manages for you and says, oh, you're trying to get to this address space. Well, that's on this node, right? That's the overlay network dedicated to this node, okay? Now, if I kind of scroll down here, we kind of create a nice picture that I think shows this all together, right? So, the service Cider, if you look at your services, that's where they come up, the cluster IP for the service Cider. If you were doing a service of type load balancer, that's where you see the external IP pop in. In this case, we didn't do that. You can see our pod IP addresses all here. These are all coming from the pod Cider. Oh, sorry. Let me jump in here. Yeah. Okay, let's do this. This is annoying. Okay, let's pop that out. Okay. So you see our pod IP addresses here, and then you'll see that it's also associated to these address prefixes in the route table. So that's how everything ties together. And then finally, in KubeNet, your nodes are on this subnet Cider. All right. So let me just scroll through here real quick, see if there's anything else that I wanted to make sure we covered, but I think that should effectively show the details of how this routing works, right? So how we're actually getting traffic from one through to the other. Any questions on that before we jump into Azure Cni? All right, cool. Yep. So there is another, so we can dig into the IP tables on this. Just to show one thing really quickly that I think I did show in here. I did. Okay, let me grab this command really quick. So I mentioned the natting, right? That we're going to nat the traffic as it comes out, right? So this line here where the external user sees that node IP, well, how does it decide when or when not to nat that traffic? So that in Kubernetes is actually handled via IP tables, right? So if I clear this, and I'm not going to get into the details of IP tables right now, but I can show you here that effectively it's going through the post routing chain. So if you look at IP tables, and I know this is going to need a sudo, I have to fix this. If you look at the post routing chain, which is essentially like the last chain that's occurring in routing, and you can see here, there's this post routing that occurs, right? And the important one that shows here is, first of all, anytime you do a source NAT, it's by getting passed into the masquerade chain, right? So, IP tables is basically chain passing to chain passing to chain, right? It's handing things around. If you send your traffic to this masquerade chain, that's where it's going to end up doing that source NAT. So if you look at this, the important thing to note here is that basically saying, look, if the destination is not my subnet cider, sorry, my pod cider. If the destination is not my pod cider, so it's not the 10.100/16, then you should source NAT the traffic, right? And that's why if we're sending traffic out, from one node to another, right, it's not going to, if we're trying to get to this node, it's not going to source NAT that traffic. So then it hits the Azure route table, and boom, we're in our node. All right, that was a lot. Let's jump into CNI. Actually, let me check the chat really quick. Okay, what's the difference between how CNI and Calico handle the network, and which is better? So good question. We'll talk about CNI a little bit, but the question is, what's the difference between how Azure Cni and Calico handle their network, and which is better? I mean, so one, as far as AKS is concerned, there is no support for Calico network plugin. There's support for Calico network policy, and the way that that's handled is by what's known as CNI chaining. So it basically kind of attaches Calico on to Kubernetes or Azure Cni, right? So, as far as the comparison from a network plugin perspective between Calico and say Azure Cni, there's a lot of different feature differences between the two. I don't think I have a side-by-side comparison of those, but as far as AKS is concerned, there is no option to run the Calico network plugin. Okay. One thing to note is that AKS will reserve IPs from the subnet by number of nodes times the number of pods per node. So the subnet size will need to increase as well. That's correct. Yeah, so that is a good point. I think I may have mentioned that a little bit before, right? When you look at, oops, wrong screen. When I jump back to here, for CNI, this one. Like I mentioned that here, right? That we're going to have the number of pods as the default is 30 plus 1 for the node. Those get pre-bound. If you go and look at the NIC, you will see those private IPs bound to the NIC, right? So they're eaten. Like it's not that every pod gets created, consumes an IP dynamically. They're already attached to the individual node. So for customers who are like, look, why are you making me use all this address space? And then you're actually blocking the IPs, there's some frustration there that we run into sometimes. So, but that is a good thing to be aware of, that those are bound to the NIC as soon as the node starts up. All right. Let's jump into CNI. And I have this diagram that I just showed you up on the site, so you can take a look at that. Let's take a look at CNI. All right, so effectively the same setup, right? We're going to create a Kubernetes cluster in this case, a CNI cluster in this case. And you'll notice a few things that have changed here. Not much, but then most notably is the network plugin we're switching to Azure, right? So we're not setting it to Kubernetes, we're not setting it to default. We're still providing a subnet IP, or ID, sorry. We've dropped the pod cider because, as I mentioned earlier, we don't care about the pod cider anymore. The pod cider is irrelevant because the pods are going to be on the subnet. we do still need to provide a service cider. And I don't think I mentioned it before, but this DNS Service Ip, that's just allows you to set the IP that's used for the core DNS service. It just has to be within the service cider. By default, it ends up being .10, but you can really set that to whatever you want if you have a preference there, which I don't know that most people do. Okay, so again, same thing, same setup, create a cluster. This time we're gonna use CNI. We're not gonna give it a pod cider. We're gonna get credentials, apply this Nginx deployment, and we're off and running. So let's take a look at this really quick. Exit out of this node. I'm gonna do switch. Let's jump over to my CNI cluster. First, let's get our service and pods. Get. Okay. Here we can see our 3 pods. If I've done out wide, I assure you that these are across 3 nodes. I just forgot to add the flag. Okay. Actually, let's do out wide because there is something I should show there. So first thing you'll notice is that these are now .220 addresses. Well, let's do a get nodes wide. And look, these are also 220, right? So we're now looking at the same address spaces for our pods and for our nodes. Okay. So let's take a look at how this actually works. So let me grab a node name. And apologies for the background noise. Welcome to Brooklyn. All right, cool. All right, so now we're within our node, and let's basically go through the same deal. Let's take a look at. I'll switch over here to make sure I'm looking at the right thing on this side. So I have my right samples. There we go. So let's run through the same process. First, let's actually get a container for Nginx. You can see I have one right here. I'm gonna do the same thing where I get the process ID for it. So let me inspect. Here's my process ID. I'm gonna enter the namespace and execute a command. So I'll give it that same process ID. Okay, so it looks pretty similar, right? So this case I have interface 10, or index number 10, ETH0 at IF11. So what are the chances that I have a interface number 11 on my host? Probably pretty good. There it is, okay? So this one looks a little bit different, right? So I have my interface index 11. It's not a VF, but it is really. It's just gotten a different name. It's still a virtual Ethernet interface. And again, you can see this one is at 10. Well, this is 10, right? So these are linked together. This interface is directly linked to this one, okay? And like on the other side, on the Kubernetes side, we were connected to CBR0. Well, for Azure Cni, there's a different bridge network. It's called Azure 0. So let's clear this out. And just like we did on the other side, we know there's a bridge network called Azure 0. Let's see what it looks like. There it is. Now it's effectively looks the same with one caveat. You may not have noticed on the other side, but with Kubernetes, the ETH0 interface was not on the bridge. It's its own thing, right? With Azure, the bridge name, or the bridge actually has ETH0 on it, which is interesting. And the way it plays in is if I take a look at the routes, so we do the same thing, look at my routes here, check this out. Nothing routes to ETH0. Everything goes to Azure, right? So whether the destination is the default route, it should go out to the subnet. If the destination is, within our subnet range, or within this, it's effectively our pod range, it's going to go to Azure 0. So everything goes through this Azure bridge, right? So that's basically an indicator that in many ways from a Linux networking perspective, ETH0 and our pods are treated kind of the same, okay? Now what this doesn't show, if I go back and do that IP address list, if you take a look at that Azure 0 interface here, you'll notice, actually it does have it there, but what's actually assigning that IP address to the nodes? In fact, you can see this is actually the specific IP address of the node that it's giving. What's actually assigning the address to the node? So if you go and take a look at the Azure Cni documentation, and I think that I have it linked here, find it. Yeah, I will share this really quick. So you can see here, from this diagram, here's my services. It's still, it's still a overlay network for the service cider. You can see my subnet. Cider is used for both my pods and my nodes, right? So that's where you can see that. But what I wanted to jump into is if we scroll down here a little further, let's take a look at here. So if you take a look at the Azure Cni Docs, and you want to see like what the Cni plugin is actually doing, because the Cni plugin is actually an executable that gets deployed onto the node. Well, if you take a look at it, it tells us in the docs that we can actually check this log file to see what's going on. So let's actually tail that log file. Okay, now what you can see is with this log file, effectively all of the network operations that are happening within the node are being, from a Kubernetes perspective, are being dumped out to this log. So let me do something really quick. Let's actually try to remove and recreate that deployment. Okay, so it's going to fly by. Ooh, you just saw it right there. Del command completed. You may have seen it pop up on the screen. What happened there when I deleted that deployment, Kubelet told the Azure Cni plugin to execute a delete operation. Okay, let me apply it back in and let's see what happens. All right, I'm gonna exit here so we can see it happen. And let's cancel this and let me kind of scroll up through and you can see add completed. Now, if you scroll through, I'm not gonna go through all the details of this, but I kind of provided an abbreviated version of this. In fact, I'll actually jump to that because it might be a little bit easier to see. But what Azure Cni is doing is when Kubelet says, hey, I have a pod to deploy, it runs a bunch of things. And the summarized version of it is it says, hey, look, there's a new pod to be assigned. So trigger the add on the Cni plugin, right? So first thing, trigger that add, okay? Cni is going to check out the network configuration and find the subnet Cider. Then it's going to call the IP address management plugin. So there's actually two plugins. There's Azure Cni and there's an IPAM plugin. So it actually is going to call out to that. That's where the magic happens. It's going and saying, hey, what IP addresses can I assign to this pod? And it's really looking at those node IPs that are bound to that pod, right? So it's picking one that's available and it's saying, hey, look, I found one. It responded with, when I ran this previously, 220.211. And then Cni does all that wiring that we ran through, right? So it creates the VF pair, it creates the ARP entry. This is spelled wrong. It should be ARP, not APR. It creates the assignment of the link. It does all the details that you need for that. Okay. Whew. Okay, so let's jump back over and kind of walk through this. That was a lot to cover, but to walk through again this flow. Let me kind of hide it for a bit again. It looks almost exactly the same, right? So we have containers, multiple containers. They have an index and an interface that they're pointing to. At the pod level, again, we have a index. This actually should say AZ something, but it's still a VF. Doesn't really matter. Okay, that's because I'm looking at the wrong one. This is the one. Sorry, because it looks so similar. I didn't realize I was doing that. Right. So this is going to that AZ interface, right, which is then connected to the Azure Zero bridge along with ETH0, right, and then down Cni, Azure Cni and the Azure IPAM, right, the IP management that's deploying and assigning all those IP addresses and basically building this whole setup for us. Okay. Now, because we're doing that, we don't have that route table. So if you look at the managed cluster, like we had on the Kubernetes side, we had that route table that's basically handling traffic that exits the node. We don't have to worry about that on the Azure Cni side, right? Cool. So that was a lot to run through. I could spend some time answering questions. Let me jump back to our doc here. So there's actually a few other things that I wanted to cover. But before I do, let's take a look at the chat. All right. So they tried, someone tried to change the pod count and reverted back to 30. Yeah, 30 is kind of it's a comfortable number for most deployments. My experience, Azure Cni makes the security team happy due to pod network visibility. So that's an interesting point. And this is something that you should be aware of. And I think we should run through at least one thing that I don't think I showed here. But if we jump to the IP tables side, and I'm going to skip ahead just a little bit. I'm not going to go through all of this IP tables overview, right? I'll just talk through it rather than executing the commands. But this is something that everyone should, if you're interested in this level of detail, should run through this. Because I basically ran through for Kubernetes and for Azure Cni, what happens in IP tables, right? So as traffic's coming in and out of services, what's actually happening. The reason I want to show this is, and first of all, at a high level, what happens is any traffic that comes in service is going to run through a couple rules, but ultimately it's going to say, hey, go, if you're trying to access, in this case, look at Nginx, it's going to say, hey, go to this next chain, right? This is the service chain, okay? And if I scroll down a little bit here and take a look at the service chain, you can see that what's happening here is that it's basically doing the load balancing. So it's a statistic load balancing here. So it's just doing a straight 30% for traffic, and anything that falls over goes to this where there's 2 nodes left. Again, read through this on your own. But what I wanted to get through ultimately gets down to the pod level here. What I wanted to jump through is if we get down to the bottom here, is that there's this one additional chain in IP tables on Azure Cni that you'll see. It's part of the post routing chain. All right, so if I go just grab this and let's switch, clear this and run this. Okay, you'll see there's this Ipmask agent that's referred to. Okay, and it's at the very end, right? So post routing again is the end of the flow. Let's take a look at what that Ipmask agent chain looks like. Okay, so here you can see, and in fact I tweaked this, so you're going to see more, that basically there's a row for, this is our VNet Cider, this is our subnet Cider, this is our service Cider, right? And this is one that I added, right? So what this means is, this is the Ipmask agent. It's going to just basically return traffic, which means just go ahead and let the traffic flow through if it's destined for the VNet, the subnet, or a service, right? It's going to do that. Well, what if the traffic is destined for another network, right? So if the traffic is leaving your virtual network, then it's not going to get straight returned. You're going to end up going through masquerade, right? So what this is telling us is traffic destined for outside of your VNet is actually going to end up getting translated to the node IP address anyway. So you can tweak this. There is a config map. So if I do K, get config map. Oops, because I'm not in here. Let's do this. Okay. So let's take a look at this config map. So this config map has a section called non-masquerade ciders. This is ultimately, this is the Ipmask agent config. This is ultimately what creates these IP tables entries. So if you wanted to not masquerade or source NAT your traffic to a given VNet, you can add a role in here. The thing to be warned of, though, is that a pod isn't a VM, right? So if you have virtual appliances in the middle, they might just drop that traffic because it's coming from a pod. It doesn't have all the attributes of straight NIC traffic. So it's something you should be aware of, something you should be cautious of. But if you see cases where, hey, look, I don't understand why I enabled Azure Cni and I'm not seeing the pod IP, well, you're probably going across networks. You're probably leaving the VNet to another VNet. And because of that that target destination, it's going to get natted anyway. Okay. So again, I would look through that. If you're interested in this level of detail, you're interested in that, I would definitely take a look at the that IP tables overview, because I know we're getting a little short on time. There was a couple other things I wanted to make sure that we hit on. Real quick on the questions. When should we use Kubernetes over Azure Cni? It really comes out. There's 2 schools of thought. I mean, I say in general, if you have the address space, use Cni, right? Because it's going to give you all of the options that you need, right? If you're not super restricted on address space, Azure Cni will give you all the bells and whistles that you need. Frankly, it's where I think that the engineering team puts a good bit more of their focus. So features tend to come to Cni first. Windows containers are only really supported on Cni right now, right? For example, so if you get into hybrid clusters. So if you have that option, go Cni. If you are restricted on address space, then Kubernetes is not a terrible option for you, and it generally provides most of the functionality that people need. You'll probably end up using network policy, just because you're not going to have as much control, but you probably end up using network policy anyway. Not really related, but question regarding Azure network policies: is it possible to monitor blocked traffic in Azure Log Analytics, similar to? Yeah, so you should be able to see the NSG logs. You should be able to see as far as I guess blocked network, Azure network policies. I mean, you would look at the NSG logs to see any blocked network traffic. Don't know that you would see anything beyond that. Like if you were just getting dropped because of some other issue, I'm not sure what, if you would see that. But maybe I'm misunderstanding the question if you want to rephrase it. Before we wrap, I know only a few minutes at the end for questions, but I did want to talk very briefly about Windows networking. We can do a whole nother session on this. But Windows networking, there's a great overview that I linked here. When you look at Linux compared to Windows, a couple of things. First of all, Azure Cni is required, although it is supported. I should fix this. Kubernetes is supported in AKS Engine, which is the upstream project for AKS. So technically, it's possible to use Kubernetes with Windows containers. And there's an open issue tracking the feature request. So if you do have a need for Kubernetes on Windows, you should check out that issue and provide your feedback there, because there just really hasn't been that much demand for it. As far as the differences, the Linux bridge network that we had in the Linux side is translated to host networking service effectively on the Windows side. All this stuff that happens in IP tables gets translated to virtual, vSwitch, virtual filtering platform, distributed router, all these components. It's all described in that overview that I shared. Okay. I talked about how IP tables come into play. Network policy, Azure and Calico. So this is effectively if you're doing network level, low level security policies, for traffic, like, hey, this IP address can talk to this IP address on these ports. You would want to use network policy. I prefer that, I think most people prefer that you use Kubernetes network policy where you can, just because of the level of control that you have. I mean, arguably, it's, anytime you can apply network policy at the lower levels like NSGs, you're going to have a better overall experience as far as performance. But if you want the ability to have, namespace-driven policies or label-based policies and things like that, using a network policy, a Kubernetes network policy implementation is a good idea. Generally tend to recommend Calico right now just because it has a good bit more features than Azure network policy for Kubernetes. Maybe that'll change over time. It's open source Calico, it's free. It doesn't hurt you or cost you anything to run it on a cluster. And you always have the option to take a look at Tigera Enterprise Calico. Okay. So one last thing I want to hit on before we close, but I did want to answer a couple of questions here. All right, which network policy is recommended? I think I just answered that. I generally tend to prefer Calico. The Azure policy roadmap, I've asked the engineering team what their plans are there and haven't heard anything back yet. There's definitely features in Azure, the Calico that aren't available in Azure yet. So I think we still tend to refer to recommend Calico as an option. Do Kube network policies get translated to NSG rules? No. That's one of the things that I asked the Azure network policy team is, could we have that translation? I mean, there are things that get translated into NSGs if you're in KubeNet and you're exposing things, in both KubeNet and Azure CIs, you're exposing things. Network security group rules will be created for anything you're exposing as a service. But if you want something more advanced, like, if you're an Azure Cni and you wanted a policy to block access between pods and have that translated into an NSG, that sort of thing doesn't exist today. Yeah, as far as the next question, when Azure network policies drop traffic, I believe it can, but honestly, I have not dug into that in a while. I haven't played with the network policy management, the logs, so I'd have to take a look at that. When would I use an internal load balancer, service cluster IP? They don't load balance the traffic to the services anyway. Okay, so good question. So you can, based on what we saw in the IP tables, a couple things to be aware of. So first of all, anytime you're exposing a service from your cluster of type load balancer, you're going to end up getting an internal load balancer. Whether you want internal or external load balancer is entirely up to you. You have that choice. You can set it via annotation on the service object. You just say like, hey, internal equals true. You can even on that service object specify that you want your load balancer to go to a specific subnet, right? So you have control over those kind of things. The thing to keep in mind with the load balancers are that they're pretty basic, right? And if you look at the Azure load balancer and what algorithms it uses to load balance, it's a hash-based algorithm by default, which is pretty solid. But it's not going to do a very intelligent load balancing like you might see, EWMA on the Nginx side, right, where it does kind of a bit more of an intelligent load balancing. So typically what you'll have is an Azure load balancer sitting in the front. And then if you want kind of a more intelligent load balancing on the back end, you introduce an ingress controller, and ingress controller algorithms tend to be a little bit more advanced, right? Because even once you saw, when we looked at IP tables for a given service, it's a statistic load balancing, right? It's not doing a very intelligent job. Whereas like a, UMA load balancing is going to look at, the latency from various endpoints, the health of various endpoints, all that good stuff. There's one more thing, I'll answer the last questions, but one more thing I wanted to show. I meant to get into debugging. And one thing, you already saw me looking at SSH jump, but you can also, if you're trying to debug traffic in and out of a node or traffic in and out of a pod, you can also use TCP dump, which is a, it's a network level monitoring solution. There's a great zine from Julia Evans on this that you should definitely check out. Actually, I have like a whole book of her stuff here, which is excellent. I highly recommend it. But one other thing, so TCP dump will show you that traffic flow. Ksnif is an open source project that actually will essentially inject TCP dump into a pod for you and then ship the data out to Wireshark. So let's take a look at that really quick here. Let's jump out of here. All right, so let me get pods again. Let's get a pod name. I'm actually going to do kind of split screen here. And let's do this out to out wide. So we can get the IP address. All right, so let me grab one of these. I'll grab this other IP address here. And let me just curl that. Hopefully I still have curl installed. I do. Okay, cool. So if I actually wanted to see the traffic in and out of this pod that I just curled, I can actually grab that. I have the plugin installed for Ksnif. So let me paste the pod IP address, or sorry, the pod name in. And the destination that I'm hitting, I'm actually going to filter this. So you can apply filters on this just like you can with TCP dump. I really only want to see the traffic that's coming and going to this IP address. So what you see here is actually going to pop open Wireshark for me. And I'll start to see that traffic flowing across, which I think is really a cool thing when you're trying to figure out exactly what the hell's happening with your pod traffic. So really not much is happening right now because I haven't sent any requests. So let's jump back over here and let's hit that curl again and jump back to Wireshark. Boom. Now we can start to see the entire set of traffic, all the TCP packets that are flowing back and forth. I'll probably see an ARP request come through at some point here, right? But you can then really kind of drill down using Wireshark and see exactly what's happening in here at a super low level. So very. With that, 2 minutes left. Let me just check back on the questions. Okay. Isn't SSH jump pod in the same cluster bad? Yeah, I mean, so I just use SSH jump for testing purposes. If you were trying to do this yourself, you'd probably create a jump server and do it something maybe a little bit more secure, especially for production, right? But as far as doing your own testing, SSH jump is very useful. It saves you a little bit of extra work, especially since I'm not locally connected to my Azure network, and my networks are coming and going all the time. Okay. If anyone wants to change network policy to Calico, the approach to what to do it would be to migrate workloads to a new cluster. Yeah, so today you can't add Calico to an existing cluster. It has to be done at cluster creation time. So you'd have to enable it. I mean, so I generally say, look, if you're cool with Azure space and maybe if you don't have a need for network policy right now, using Azure Cni plus Calico is going to give you kind of all the knobs and dials that you could need as you start to move forward. And it doesn't cost you anything extra apart from the Azure space that you can eat up using Cni. All right. Cool. Awesome. Any other questions? Cool. So I think we're at time. I don't know. Sorry, Dave and Kendall, I didn't leave you much time at the end. As expected, I went on for a while. But yeah, any other final questions or any kind of wrap up details?
I thought that was great. So no apology necessary. I think everybody probably learned a lot.
Awesome. You also get to learn how cold it is in my place. I'm like wearing a beanie. It's like freezing. There's like noise outside. Welcome to living in Brooklyn. All right. Cool. All right. Well, thanks. I don't know if David, David, can I wrap up or we'll just close it out? All right.
Thanks, everyone.
Thanks, everybody.
Appreciate it.
Take care. And
We'll
again,
post
I'll
the
share the link in
recording.
the chat. We'll make sure that the link is out in the notes as well. So you should have everything that you need if you want to play through this stuff.
Thank you.